Hello, my name is Patrick Tinsley, and I'm going to be presenting on This Face Does Not Exist, But It Might Be Yours, Identity Leakage and Generative Models. And I worked with Dr. Adam Shaika and Dr. Patrick Flynn at the University of Notre Dame for this project. So the motivation for this work stems from the idea that identity information can leak from the real images that are supplied during the training process to the generated sample images at the end of the generative process. And so we're using the StyleGAN2 generative model in this case from NVIDIA, which generates photorealistic high-resolution images of really whatever you feed into the training data set. The second question that we have to ask about that is, if we do see identity leakage, could this be considered a threat to privacy, a potential threat to privacy? And so to quantify the similarity or dissimilarity between these images of faces, we used 5 different models. You can see these in the face matcher details table. The first 4 are open source, whereas the last is a proprietary commercial face matcher. And so once we have face embeddings or feature vectors extracted for all images, real and generated, we can start to compute distances between these vectors. And these can be used to see, you can see these as similarity or dissimilarity measures between two images in a pair. Real and real image pairs are half the battle, and the other battle is real and generated image pairs. And so if we see that there's a difference between these distributions and scores, then we can start to formulate some ideas about whether or not identity leakage is readily digestible. The first thing that we did, however, was rank these models in terms of performance, and we used the D prime metric as our metric of choice. And we came out with the ranking of Megamatcher, ArcFace, face recognition, sphere face, and FaceNet. And this D prime metric really just quantifies the difference between two distributions. In this case, it was genuine versus imposter. However, for the real versus real and real versus generated scores, we saw something a little bit different than what we saw previously. For ArcFace and sphere face, we saw that identity leakage is evident. And you can see this in our tables, but also in the graphs. This leftward shift for comparison scores indicates that the generated images are actually closer to the real images than other real images are, meaning that some features, some facial features are being leaked somehow through the training process for ArcFace and sphere face. However, Megamatcher, FaceNet, and face recognition do not support this claim of identity leakage. So there is a bit of ambiguity and inconclusiveness, but that I don't think is so much a detriment, because that could be seen as an interesting facet to these experiments. And so if we were to go and revisit our original motivations, we say that yes, identity information does leak for some models, where for other models it does not. And since it was the case for some models, there is a potential threat to privacy if you do use these models. For instance, ArcFace is a very robust face matcher and used pretty frequently. So if we were to say we wanted to have a threshold or acceptance threshold of 0.1 for real versus real face matching, then we'd have a cutoff score of about 0.45. However, if you threw a generated image in there, you see that the false match probability actually jumps up 6 times when your image is included in the training set for StyleGAN2, if you do use the ArcFace face matcher. And so the inconclusivity really lends itself to a lot of future experiments. We want to retrain StyleGAN2 a couple times with different data sets and see if it persists across different data sets, and even furthermore test this against other modalities in the biometric sphere. Thank you for the time, and looking forward to sharing more work with you. Thanks.